Welcome to Train Signal. I'm Chris Bryant, CCIE number 12933, and this is your troubleshooting video. This is actually my favorite thing to teach. I love teaching troubleshooting. I love troubleshooting, and frankly, we all better love it because frankly, as network admins, it's what we do about 95% of the time. We don't go in every day and install new things from scratch and assign IP addresses, that kind of thing. We have to know how to do those things to be a world-class troubleshooter. But the truth is, we're answering the phone, we're answering calls from end users, from junior network admins, senior network admins. Hey, this isn't working. Hey, this looks slow. What do we do about this? That kind of thing. So we've got to become world-class troubleshooters, and that's really what this video is aimed at helping you with, especially if you've never touched a network. Because this can be the most daunting thing to get started with, and we've all been there. I know there are some senior admins out there who act like they've been senior admins all their life, but as a CCIE, I can tell you I've been there troubleshooting printers. I'm still there once in a while because we've all got to do some troubleshooting sooner or later. And whether it's we're troubleshooting printers or we're troubleshooting wide area network connectivity, the processes are really much the same. And we've got to have these tools, and we've got to know how to use these tools so we can figure out what the problem is and get it started. We're going to talk about where to begin as far as getting started because, as I'll mention a couple of times, really, you've got to have a structured approach for troubleshooting. I mentioned that during the OSI model lecture because I personally use the OSI model as a structured approach to troubleshooting, and I hope you'll do the same. We're going to talk about Cisco Discovery Protocol, CDP. That's going to help us get an accurate picture of the network because, as I'll mention, sometimes being a network admin, especially if you're on call to different sites or you go to a new client site, it's a little bit like being a detective at first because people are going to tell you one thing, and then when you start digging into the network, you find another. And CDP can really help us get an accurate physical picture of the network. We're going to talk about troubleshooting really at all three layers that we're dealing with: physical layer, the data link layer, and the routing layer, the network layer. We're going to go through a LAN troubleshooting example and a WAN troubleshooting example as well, and those will incorporate extended ping and traceroute. Now, throughout the course, we've used a regular ping. Now I'm going to show you extended ping and some options that go along with that. We're going to briefly review Telnet and SSH. We're not going to go over everything that we went over in an earlier video. I'm going to remind you of the key points as far as passwords and enable modes go. I am going to show you some maintenance commands for Telnet sessions that I think you should pay particularly close attention to. I will also introduce you to the concept of administrative distance. This is going to involve a routing table with several different routing protocols in it, a couple that you haven't hit yet in your studies. You may be familiar with them from your job, but if you're not, don't worry about it. You don't need to master the protocols to understand what administrative distance is all about. Finally, I'm going to wrap it up with a little bit of a talk about the real key to troubleshooting and becoming a world-class troubleshooter. I'm also going to work in some real-world examples here, and don't worry, I know that we're concerned about passing the exam, and you're definitely going to get there. But as I'll mention during the course as well, there are two parts to becoming a real-world troubleshooter, and one of them they're not going to test you on. We obviously have to have the knowledge behind the protocols, behind the switches, behind the routers to be effective network troubleshooters. But you know, anytime you get called in to troubleshoot something, I don't care if it's a router that's down, an entire wide area network is down, the company can't communicate, or the boss's secretary can't send a job to the printer. No matter which one that is, it's vitally important to the end user, right? It's vitally important to that customer, and they're probably not in a good mood. Like I said, I've done desktop support. I know what that's like to go to somebody for the 5th time. The printer's not working. You know, well, the last 4 people couldn't fix it. I don't know why you're going to be able to fix it. You know, that kind of thing. We just have to deal with that. So obviously that kind of thing is not going to be tested, but we are going to discuss it here during this video because it's not just the routers and switches and printers and PCs we have to deal with. We also have to deal with the human element when we're troubleshooting. But we're going to pass over that right now because we're going to get started with a talk about where to even begin troubleshooting. The first troubleshooting mantra I will teach you, so to speak, is to always begin your troubleshooting at the physical layer of the OSI model. And I say this so often that I've got non-technical friends that will say it, hey, something's wrong with my PC, so I always start at the physical layer. They don't know the other layers of the OSI model, but they know the physical layer, because I'm always telling people, always go to the physical layer first. And with troubleshooting, as I'll mention a couple times in this video, you really have to take the human factor into account. And one of those factors isn't with our end users or our clients, it's with you and I as network admins. Because sometimes we get a little tunnel visioned and we don't really look at the big picture, to use that dreaded cliche. We're not looking at the entire picture here. And when it comes to, I don't care what it is. I don't care if it's a server that isn't doing what it should be doing, maybe a router's not doing what it should be doing, or you can't send a print job to the printer, whatever. The first thing you do is check the physical layer, and that's just a fancy way of saying, first off, is this thing on? Yeah, and we've all been through that as network admins. You get there, an end user calls you, or you go to the vice president's office to check on something, and maybe you're a little rattled, maybe you're a little distracted. You start looking, for something fancy on the PC that's wrong, and hey, a cable got kicked loose. It's just simply off. And speaking of that cable, do we have the right kind of cable? And we've talked about that a little bit in troubleshooting when it comes to the crossover cables and the rollover cables. We're going to review that in a moment because it is really important. I expect you to see that on your exam, but of course in real world networking, if we don't have the right cable, then we're out of business. And this third one, I'm going to mention this too, has the cable come loose just enough to bring things down? And that can be true of a router. That can be true of a printer cable, especially the ones with those big whopping cable ends, right? Those big connectors. Well, they can come just loose enough so the print job can't get where it needs to get, but it looks okay. And this is particularly true of routers that are in a crowded cabinet. And, just being realistic here, most cabinets are crowded. When you open up your average cabinet and you're looking at all these routers and switches in that cabinet, there's generally not a lot of room to spare. So you could be looking at a switch in there, and what happens is, unfortunately, and this is just real world, you've got to push some cables aside with your hands to see port lights, that kind of thing. We've all seen those cabinets, and if you haven't, believe me, you will. And by moving those other cables, you might loosen another one just enough, or might nudge it just enough. That's particularly true of a serial cable that's attached to our serial 0 interface on a router, say. And it gets nudged a little here and a little there, and one day it just gets nudged enough where it comes just loose enough to go down. So you want to watch that. If you have, obviously if a serial interface goes down on a router, it's a pretty serious situation. You can't panic though. The network admin has to remain calm. We're going to let everybody else run around flapping their wings. We have to remain calm. And the first thing that I do in that scenario is I go right to that router and right to that cable and make sure it's connected. And of course, we've got show interface serial 0 that helps us out, and we're going to review those settings here in a moment as well. But when it comes to the right cable, let's remember those basics. Crossover cables, we need those for trunking. We're going to connect two switches with a crossover cable. Rollover cables, that's what we need to connect our laptop to the console port of a router, and you may need an adapter to use a rollover cable with your laptop today because it's unlikely that you have that one particular port. You're going to have USB ports on your laptop these days, and what you need to do is just get an adapter, make sure you've got one. Now, regarding that second bullet point, make sure that you have the rollover cable connected to the router's console port, not the auxiliary port, because on many routers they're right next to each other. They both take RJ45 ports. I've done it before. If you've got a home lab and you're moving things around too, and you take your rollover cable and you plug in the auxiliary port, it can come up and ask you for a password and then say no password has been set. And your first reaction is, who set a password here? But what you want to do is just take a moment and say, wait a minute, am I connected right? So just make sure that you're connected to that console port and not the auxiliary port. Now, some networks you're going to work on in life have nice, neat, clear, concise network maps. and they're going to show you every router and every switch and every physical connection, and they're all going to be clearly labeled. But some networks do not have that. Now, part of troubleshooting, I mentioned the human factor a moment ago, and the human factor is not something that Cisco is going to test you on, but it's an ability you have to develop as a network admin. Because I'll occasionally say, you know, dealing with the routers and switches is the easy part of being a network admin. It's dealing with the people that really does separate the world-class network admins from the not so good. And that really is true. Because let's face it, you know, most of our end users, they don't get upset slowly. You know, if they can't print something, they're not going to be happy. If they can't get their email, they're really unhappy. It's always a contest to see which one gets people madder, you know, printing or email. But it also comes to that with our networks. Because just because a client says, well, you know, yeah, we've got these two devices hooked to each other, this router is connected to this switch, etc. You know, I'm not saying they're lying to you, but they may be misinformed. Or they may just be saying the wrong thing. They may be misstating it. So you can talk to your client about this kind of thing, but you also need to quietly verify what they're saying. And those of you, if you've got any kind of law enforcement background as I do, a little one that is, you know that, you know, sometimes people just, they know one thing, but they say another. And that's really true of networking as well. Yes, I know that this is connected to this. And then you get into the network and you find out it's not really that way. Well, an important tool that will help you really get the facts and just the facts, ma'am, is CDP, Cisco Discovery Protocol. You can check a Cisco device's physical connections to other Cisco devices with CDP. Now, the theory of CDP is that it runs by default on all Cisco routers and switches, both globally and on a per interface level, which means we can turn it off and on at the interface level, or we can turn it off and on at the global level. The commands are different, and I strongly suggest you have these straight in your mind before taking an exam. Cisco exam, because it's a bit of a joke that at every level of every exam they seem to ask something about CDP run and CDP enable. I half expected it to see it on my CCIE lab the day I went in and took the lab. Now, for security purposes, many admins choose to disable CDP, and I'm not going to get into a discussion here whether that's right or wrong, but again, a lot of times when you go into a network, CDP will have been disabled. So here is the command to see if CDP is actually enabled on a router or switch, and it's simply show CDP. These are the global defaults for CDP. CDP packets are going to be sent every 60 seconds. The hold time value is 180 seconds. We'll discuss exactly what hold time means in a moment, but you can probably just guess from that. And we are sending CDP version 2 advertisements, which is the default. Now, this output again means that CDP is indeed enabled. So let's check all our devices. We've got 3 routers and 2 switches here. And what I did is a write erase on all 3 and then rebooted them. And let's see if it is indeed. Now you'll notice that router 2 didn't say CDP version 2, but that's no big deal. And CDP is spelled CDP. And there we go. There is no such thing as CDEP. So it's running by default here. The reason I showed you that is that every once in a while you'll bump into a router or switch that isn't running it by default. That usually happens, frankly, in a home lab environment when you've rebooted a switch a great deal and done a lot of write erases on it and reloaded it. Occasionally in that situation you'll see it not on by default. But again, the theory is that it is on by default globally and on a per interface basis. If we want to turn it off, it is no CDP run. And then when we run show CDP, you know how I've mentioned several times that when you run a show command, and if there's nothing to show you, you just get an empty line, and we've seen that a couple of times. You actually will get a message from the router saying CDP is not enabled. And then we'll just turn it back on in global mode with a CDP run. And you can see it's back on. Show CDP neighbor, we're going to take quite a look at this, but you'll notice this table is empty right now. The CDP neighbors are not going to show up immediately once you turn it back on. You've got to give it a little bit of time, usually about a minute or so, for them to all show up. So we're going to go to one of the switches right now and take a look at show CDP neighbor. This is probably the most common command you're going to use. And right now you can see the reason I wanted to show this to you on a switch also is that you'll notice under device ID you see switch 2, SW2, twice. There's nothing wrong with that because you'll notice that the rest of the information, local interface and port ID, these are different. These two switches are trunking, and for redundancy I've got two cables connecting them. What kind of cables am I using for that? If I'm connecting two switches to form a trunk, I'm using crossover cables. So again, it's not necessarily an error if you see the same device ID there twice, but what you should see is that the local interface and port ID are indeed different. Now again, for security purposes, many admins choose to disable CDP. We looked at show CDP several times there. That's how we show that it's off, and the router is actually going to tell you that. Now, I'm going to leave this on the whiteboard for a moment if you want to print this out, but we're going to go from left to right here and take a look at what these headers mean, what these headings mean in each column. Device ID is simply the remote device's host name. So this is really a great command right off the bat because you could run into a client site where there is no network map. And you do what they call walking the network. You just connect to one device, and from this information you can start your network map and say, okay, I know that switch 1 here is connected to switch 2 at these two ports. Then go to switch 2 and see what switch 2 is connected to. So you just gradually build a map. You can actually see what the entire deal is. Now, local interface, that is the local switch's interface that is directly connected to the remote host. So here, with this particular connection, the local port is FAST012 and it's connected to the remote device's port ID, which is FAST012. I know I skipped there a little bit, but those two are related. The hold time is the number of seconds that the local device will retain the contents of the last CDP advertisement received from the remote host. Now, if we run the command here, we should see that that has gone up again, because remember our defaults, that it was sending every 60 seconds, but the hold time default is 180. So that gives us quite a bit of leeway. If we're still getting CDP advertisements from a downstream neighbor, this should never go below 120. Moving over, and this is even better, is that you can actually see the capability of the other device. And luckily for us, the table's right here, but I would keep those in mind for the exam. You see this device actually has two letters, S and I. Sometimes you're just going to see one. And here we've got S for switch and I for IGMP. That means it's IGMP capable. That's a protocol you don't have to worry about right now, but it does run on most, if not all, Cisco switches. So you should get used to seeing that I there, as well as the capital S for switch. Because do note here, we do have one letter that repeats itself. The capital R indicates a router, and the lowercase r indicates a repeater. That's probably a good detail to keep in mind. Platform, it even shows you what the hardware platform is for that particular device. We can see here that's a 2950 switch. With routers, we would see, 25 or 2600, 3200, whatever we have there. And again, port ID, that is the remote device's interface that's part of the direct connection. Now remember, this is for directly connected Cisco devices only. It is Cisco proprietary. You're used to that term by now. That means that only Cisco devices understand it. If we have a 3Com switch or a Nortel switch or a Juniper switch attached to this one, we're not going to see it with CDP because those vendors don't understand CDP. Now again, this is an excellent command to verify what you're being told. And I've been in more than one situation. Again, a client says one thing, CDP proves them wrong. Well, we're going to believe CDP over the client. You may want to kind of use it when the client's not looking over your shoulder, but it can also prove what you're telling the client. Here are the rest of those values: capability, platform, and port ID that you can take a look at. We're going to get to that in a moment. I'm going to show you a variation of the CDP neighbor command I'll use my up arrow there to repeat. Show CDP neighbor detail. Now, as you can see, there's a lot of detail right off the bat, and you can see it's going to tell you some of the same information. There's the device ID, there's the hardware platform, there are the capabilities, the interface and outgoing port, the hold time is right there. A couple of things that this command tells you that show CDP neighbor does not. It gives you all the information. It even tells you what the iOS version is of the remote device. That's pretty sweet. Now, it's got the advertisement version, then of course referring to CDP. Here's the native VLAN. If we were running VLAN trunking protocol, it would tell you what the domain is here. You'll learn about that in your ICND studies. And remember I told you about that management address that we could put on VLAN 1? That's known as the management address on a switch. We didn't set that, so we don't see it here. But the other detail here that you would see there for a switch and elsewhere here in this command output on a router, it will actually tell you the IP address of the neighbor. And that's the one big important information here that just good old-fashioned show CDP neighbor ignores. It doesn't tell you that. But with show CDP neighbor detail, you are going to see the remote device's IP address. Now let's take a look. There's one more thing about changing it on a per interface level. Now we know how to change CDP settings, enable or disable at a global level, and that's CDP run and no CDP run. But let's say I just wanted to turn it off for whatever reason on a particular interface. I do that with no CDP enable. Enable and no enable turns it off on an interface level. Run and no run turns it off at the global level. And I'll just turn it right back on. And that's all there is to it. I would know those commands with CDP like the back of my hand. Like I said, they're kind of famous for asking kind of detailed questions about CDP. You can also run show CDP interface. And that's going to give you the information about whether the interface is up or down, what the CDP packets is sending every 60 seconds, hold time is 180 seconds. And it's going to show you that for every interface. Now, again, with CDP, sometimes you're going to disable it entirely on a device for security reasons, and you can do more reading about that on your own. Actually, just put into Google or whatever search engine you prefer, you know, something like Cisco CDP security, something like that. I'm not saying it's dangerous to have it running, but again, you may go into a client site where it's off, so you better know how to turn it on, and always, as a professional courtesy, turn it back off as you're leaving. Let's step away from CDP for a moment now, and we're going to review these show interface outputs that we've looked at really throughout the course. I know when we were talking about some layer 2 technologies, I really drove home, you know, what the serial 0 is up, line protocol is down usually means, but I want you to have all this in one place too, because frankly, I really expect you to get hit with these hard on your exam, and for good reason, because we have to know what these mean and what to do about them. And of course, in the real world, we need to know what to do about it as well. Now, this is what we want, obviously. We've got serial 0 is up, line protocol is up, all is well with the world, and we couldn't be happier. But of course, if the interface looked like that, we wouldn't be troubleshooting now, would we? We're going to take a look here again at all the combinations of serial 0 is whatever, line protocol is whatever, and let's start with this one. And this is a classic. We've all fallen for this one once in a while. We're sitting there configuring a router interface, and it could be an Ethernet interface here too. And we set an IP address, and we do all this stuff, and we can't get anything to work. Well, always start your troubleshooting there, once you've checked your cables, with the show interface command. And here we're using show interface serial 0, and I've cut all the other material out because we really don't care about that. We're concentrating on this top line. Serial 0 is administratively down. Right then and there, you know exactly what the problem is. The interface is shut. Because remember, on our routers, all the interfaces are going to be shut by default. So that one's easy. That's easy points on the exam for you. Administratively down means the interface is indeed shut down. And you open the interface with no shutdown or simply no shut. That's all there is to it. Now, once we open that, you always want to hang out for a minute or so and make sure that the line protocol stays up, because what you're going to see immediately is a message we've seen throughout the course where it says, okay, serial 0 is up, and then about 5-10 seconds later you get the line protocol is up. Well, that message is going to come up even if we've got a problem. We just don't have the problem yet. And you're going to see what I'm talking about in a moment when we review some of the encapsulation mismatches we looked at in the WAN section. But the key here is when you see the line protocol come up after you open an interface, stick around for a minute and make sure that it stays up. So we've got success there simply by opening the interface. Now here's another potential readout. This one says serial 0 is down, line protocol is down, but as CSense and CCNAs and CCNPs and CCIEs, we know that there's a big difference between down and administratively down. Now, when you see that down part, again, the first part of this output, serial 0 that is talking about the physical status of the interface, where line protocol refers to the logical state of the interface. So this really goes back to something we were just talking about a few moments ago. Again, I can tell you, a cable that looks fully attached just may not be. So when you see that output right there, don't assume, oh no, we got a problem with the port. Don't jump to that conclusion. Make sure that the cable connectivity is there, and of course, if you find out it is there and it still doesn't come up, the cable's no good, you can always swap a cable out, because there's not a network room in the world that shouldn't have spare cables right there next to the routers. They don't cost anything, and one day you'll be really glad you had them. So make sure you've got those spare cables, and you can swap them out very quickly. Again, you don't want to shove the cable in. I've seen people occasionally get a little enthusiastic and they're pushing that connector in, like they're going to shove it through the other side of the router. That kind of defeats the purpose. We don't want to do that either. So again, it just happens over time. Cables get nudged by elbows and router cabinets, that kind of thing. And in this scenario, all I did, since it's down anyway, I just took the cable all the way out, the serial cable, and then just plugged it all the way back in. And after plugging that loose cable back in, bingo, the line protocol comes up. And we're all set because the serial interface came up. Now, there's one other reason I can think of right off the bat where a port can be down physically, and we saw this in the switching section. You have to watch out for that one, the dreaded error disabled message. Now, that happened to us when we were going through the switching labs because of a port security violation. So you can run the command I showed you at the time, show port security interface, and that's going to tell you the reason the port was shut down. But again, when you see this, it doesn't mean that you forgot to open the interface. It means the interface has been shut down for some reason. You can see those for other reasons that you'll see in future studies, but right now keep in mind that port security will cause that as well. Now, the dreaded one, the one we have to really watch out for, is this combination. Serial 0 is up, line protocol is down. And we talked quite a bit about this in an earlier video, but we're going to review it here. The first thing is when we see serial 0 is up, we know that physically things are fine. So again, when we see something like this, especially on a serial interface, we have to remain calm, but time is of the essence. And that's why I want you to run this command first, because it'll indicate whether you need to start troubleshooting at the physical layer, or is the physical layer actually okay. Well, when we see that, we know the cable's fine, the port's fine, physically everything is fine, but logically something is definitely wrong. And two major reasons you can see that on a serial interface, and the big one is that we've got an encapsulation mismatch. Remember, we talked about PPP and HDLC in an earlier video, and these have to match. Remember, HDLC is also Cisco proprietary, where PPP is not, because this version of HDLC that Cisco routers use, it's Cisco's own version of HDLC. So that's something else we have to be wary of. But here we've got the problem because we just have a mismatch, period. Once we match those back up, the line protocol is going to come back up. We don't have to reset anything. We don't have to, bounce the router or anything like that, thankfully. So we've got to watch those line protocols. And the other thing we've got to watch is that clock rate. Do we have a clock rate coming in from the CSU, DSU? In a home lab situation, or a situation where we actually have the Cisco routers directly connected, we looked at that as well. One of the routers has to be acting as the DCE. And remember, we use show controller serial X to see which end of the DTE-DCE cable was connected to that router, and it's the DCE that has to supply the clock rate. That's what we've got to watch. Now, when it comes to layer 2 of troubleshooting, here we've really concentrated on the physical side and then the logical side there with the clock rate. Got to make sure we got a clock rate coming in from the DCE. We've got to make sure that the encapsulations match up. Really, it's my experience that about 99% of your network problems are going to occur at either the physical layer or the network layer. And we talked exhaustively about switching earlier in the course, and I know you're exhausted from it, so I'm not gonna show you a lot there as far as troubleshooting it because we went over that earlier. I'm going to show you how to look at the MAC tables one more time. That's how to look at the entire table, and we've got the option of putting dynamic here at the end to see only the dynamically learned MAC addresses. A need to troubleshoot the MAC address table is very, very rare, especially when you're doing what we've done here in this course and you've allowed the switch to learn the addresses dynamically. It really is quite rare. I've been doing this for quite a while, and it's rare I've ever had to troubleshoot the MAC table with the dynamic entries. When you do run into issues on switches, it's generally because of a misconfiguration of a switching feature that you and I as network admins just put in. And we do make mistakes, and that's something some of us have a hard time accepting. But that's just something that happens, and it's not really going to happen with anything that we've looked at here. When you're studying your ICND2 and going after your NP, you'll see more and more complicated switching scenarios. But really, the need to troubleshoot the MAC address table when it's using dynamic entries is very, very rare. Now, I have this in bold and italics, so I must really mean it. I mentioned a moment ago that sometimes when we're working on a router or switch, we see an unexpected result. And later in your studies, you'll see something called an access list, and we can use that to block traffic. Well, sometimes when you're configuring one and you block the traffic you wanted to block, you inadvertently block other traffic that you didn't think about. It happens. It happens. It happens on switches. You configure port security. Maybe it doesn't work the way you thought it would. Maybe a port goes down immediately and you wonder, hey, what's going on here? Well, for some reason, again, this is the human factor. Some network admins, some people, have a tough time accepting that what I just did caused that. Well, if you're typing at a console and something goes down while you're putting a config into place, what you just did caused it. We always do that in troubleshooting. Another thing I want to share with you is that when you go to see an end user and they're saying, hey, this just happened, has never happened before, we've all heard that one. The first thing I ask in a nice, polite, professional way, what has changed here? What were you doing? And you have to be careful with that because end users get really defensive. I didn't do anything. Or the famous, it was like that when I got here. But it's like they see you coming and they see you as someone who's going to assign blame to them. And human beings don't like that. People don't like that. Even if you approach them in a kind way, they're already on the defensive. Well, we have to be wary of that because something changed or it wouldn't be broken, right? Well, we have to be wary of that in ourselves too. Because again, if you just configured something and something went down, you probably did it. There's nothing wrong with that. All you have to do is undo what you just did. That's what the no command is all about. It's no big deal. Just fix it. Simple enough. Don't look for something else to blame. You did it. Just undo it. That's part of troubleshooting too. That's the end of the philosophy lecture there. But again, I promise you, it's the human factor when you're doing network troubleshooting that you have to continually contend with. And that doesn't just go with dealing with end users who aren't always in the best of moods. We have to remind ourselves that we're human too. And we're going to make mistakes. When you make a mistake, just undo it and then analyze what you just did. You learn from it, you put it back into place, and everything will be fine. Another one of our basic tools that we have used throughout the course for troubleshooting is ping. And we actually have two different kinds of pings that Cisco routers can send. And to this point in the course, we've only looked at the basic ping, or what most people just call ping. And we simply type the word ping, put in the IP address. After that, 5 ICMP packets go out, and hopefully the echo packets go out, and hopefully the echo replies come back. Now, we're going to look at this particular scenario, and this is not a recommended topology of any kind, but this is going to illustrate a couple things we have to look out for on our routers. And I'm going to show you some typical troubleshooting issues that you run into, really on PCs and routers, just some reminders here. Now, we've got the IP addresses there. We've got a trunk here between two switches, and we've got our two routers. Router 2 is the one up there at the top that ends with the .2. Router 3 ends with the .3. And again, we know what we want to see with the ping, right? We want to see 5 what? We want to see 5 exclamation points. What we don't want to see are 5 dots, or especially that one unique combination where we saw 3 U's and 2 dots, and that meant, there was some kind of routing issue. The downstream router didn't have the route that we needed. I'm going to review all those for you in the whiteboard in a moment. But what we need, again, is that structured approach to troubleshooting. Because there are two kinds of troubleshooters in the world. There are two kinds of network admins, I should say. Those who can troubleshoot and those who can't. And it's a learned skill. And I'm still learning, and I've been doing this an awfully long time. But the key to becoming a troubleshooter is to have a structured approach. I'm going to sit down and see what the problem is. Do I have the physical connectivity that I need? Are we okay at layer 2? Are we okay at layer 3? That's why I'm so high on that OSI model that we were talking about earlier. I'm so high on it for troubleshooting. It's not just something to memorize. It gives you a plan. And again, we always start at the physical layer of troubleshooting. I have not configured anything on routers 2 and 3 right now. So let's go then to router 2. That's router 3. You can see by the prompt it says router 3. By the way, if you come into a router like I just did, and it comes up in the middle of a config, you can just hit escape and it's going to take you out to the prompt. So let's take a look then. Let's try to ping right now. Let's try that again. Let's try to ping right now. 12.23.3. Those are the addresses we agreed on. 23 there. Always make sure you're pinging the right address too. You'd be surprised how often that comes up. So we're going to try to ping router 3 right now. Unrecognized host or address or protocol not running. Well, that doesn't look good at all. So we know the protocol is running. IP is running on this baby by default. So we're okay there. So what's the first command we would run here to even begin to troubleshoot? Because we tried to ping, and obviously we're not doing too well there. I mean, that's really bad. Unrecognized host or address. That's not good. Let's take a look at the interface itself. This time we're looking at the Ethernet interfaces. And what do we see right off the bat? What have I not done? I have not opened the interface. So obviously this cannot be up. The line protocol cannot be up if you see any kind of down message here. Watch that on the exam. They might throw that. You could see that. There's no way there's no way the logical interface can be working if the physical interface itself is down. It's just not possible. So what we're going to do is open that interface. And we should see some messages here pretty shortly. We see the interface is up, line protocol and Ethernet 0 is up, and all is well. And you know what we ought to do is go over to router 3 and put an IP address on that interface, shouldn't we? It's Ethernet, so there's no need for any clock rate or anything like that. We'll just open it up and it'll be fine. See the line protocol changes state to up, interface is up. Things are looking good. We'll go ahead and verify here on router 3 before we go over to router 2. Show int E0, and we see Ethernet 0 is up, line protocol is up, all is well. You can also see the MAC address of this Ethernet interface. And there's that BIA. Remember what that stands for? Burned in interface. The reason that you see this and then what the BIA is, you think, well, you know, they're always going to be the same thing. You can actually change the MAC address assignment on this interface. You don't want to do that unless you've got a really good reason, and probably not even then. But I just want to tell you why you're seeing, here's the MAC address, or the hardware address, which is just another name for the MAC address. And then why does it say BIA after that? Because this is actually changeable. But that's not something we want to get into. So everything here is good. Everything looks good. Let's go back over to router 2. And we'll send a ping again. We'll just use our up arrow. Well, let's take a look at our interface over here. Everything looks good. Ethernet 0 is up. Line protocol is up. Everything looks fine. So we'll send that ping over to .3. Unrecognized host or address or protocol not running. Well, that's still really bad. That's not good. So, what are we missing here? What are we missing here? Let's run debug IP packet and see if that helps us out. Again, one more time, you never practice these at work. You never run a debug on a production network unless you're sure of the result. This debug in particular can really overwhelm your router. So let's see if we're going to get anything when we try to send a ping there with debug IP packet. We're probably not going to get anything. So what are we missing here? I mean, everything's fine. Ethernet 0 is up, line protocol is up. Here's our MAC address, and here's our IP address. We never put an IP address on router 2, on Ethernet 0. So, according to the diagram, we better have this IP address on there. It's not going to be there by default. We've got to put it there. So what do you say we do that right now? We've already done a no shut there, so we should be fine. Sometimes I like to do a shut no shut after putting the IP address on, but it's not that big a deal. So I'll wait for my write or my copy run start as the official command too. And there we go. And you see the encapsulation fails on the first ping packet. That's actually okay the first time you ping a new destination. You can see that the very first one failed. But after that, they all went through. We're all fine. And this time when I send one with that debug running, you'll see that they all went out and they all came back. So watch that. You know, that's a little more common than you'd think. We just forget to put IP addresses on. We're so concerned about getting everything else ready to go. But there, it's just simply, first off, we didn't have the interface open, the Ethernet interface. And secondly, we didn't have an IP address on it. And what do we always do before we leave a client site? We take the debugs off. Now, show debug will show you all the debugs that you have running. And on occasion with troubleshooting, and as your skills get more advanced, you'll run more than one debug at a time. You can turn them off individually by just putting the word no in front of it. And that will give you a message saying this specific debug has been turned off. But what I always run on the way out after I've been troubleshooting is undebug all. And that gives you the message all possible debugging has been turned off. And then I don't have to worry about what the problem was. But again, just with, or that I was still running debugs, just with this little baby network, and these could be PCs, of course, here as well. Maybe we've got an IP addressing problem. Maybe the interface isn't open. If we still weren't able to ping between those two particular hosts, I would check the VLAN port membership on the switches with show VLAN brief and see which VLAN they're actually in. We can take a look at that again. We looked at that earlier, but what is the default VLAN? Remember that one? What is the default VLAN? What's the default setting here going to be? Because I haven't changed anything. All ports are in VLAN 1 by default. That's our default setting. And we're going to go over to the other switch. Of course, you recall if these hosts were in different VLANs, we'd have a problem. We'd have to get a layer 3 device involved. Remember when we couldn't send the pings across the VLAN? So again, you can run show VLAN brief if those devices still couldn't ping each other after what we did there. And again, you'll see more of this in your NA studies, but actually we looked at that in our switching lab. I put that in for you. We had those hosts in different VLANs, and it cut down on the broadcasts, but it also meant that they could not send IP packets to each other, the ones that were in different VLANs. So you've really got to keep that in mind for the exam. So just with this little simple network we had there, we ran into a couple of things that could be the cause of the issue. First off, the Ethernet interface wasn't open. Then we opened that. On top of that, we had forgotten to put an IP address on router 2. Okay, I forgot. You were probably sitting there saying, hey, put an IP address on there. That's fine, but that could have been a problem. It could have been that they were in different VLANs and wouldn't be able to send each other packets by default. And we could have just had a loose cable. Now, we ran show interface early on, and once we opened the interface, we kept seeing, Ethernet 0 is up. Really, troubleshooting is really a test of your analytical abilities as well as knowing the right command to use at the right time. That's actually my favorite part of networking. I'll be glad to set something up for you, but I like troubleshooting. I like digging into it and seeing what's going on. Now, for real-world PC troubleshooting, you can run ipconfig all. And that's going to show you a host's IP address, network mask, the DNS server location. If I'm sitting at a PC and I know that I've got the cable up, everything's fine physically, I will run this command. Now, the Ccna exam is not a PC troubleshooting exam per se, but I wouldn't be surprised to see the Microsoft commands that I'm going to mention here to you show up on your exam because it is a basic part of troubleshooting. As a matter of fact, while we're here, I will go ahead and bring this up and we'll take a look at some information here. I just like to go back to the prompt. ipconfig, you remember that, it's going to give you your DNS suffix, but it gives you your IP address, the subnet mask, and the default gateway. Always, 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 when you've got a problem with a PC and it can't reach the rest of the network, the first thing you do is ping what? Ping 127.0.0.1. I'm going to put that on the whiteboard right here for you. That is the PC's own loopback address. If you ping that on a PC and you don't get a response, you got a real problem there at the network level on that PC. It could be the TCP/IP is not correctly installed. Maybe there's been some kind of corruption. It doesn't hurt to uninstall it and then reinstall it. But if you can't ping 127.0.0.1, the problem is right there at the PC. That's the first ping you should send. The next ping you should send at the PC level is ping whatever the default gateway is. Because if you can't ping that default gateway, that's why you're not getting out. So here, in this particular situation, 192.168.1.106 is the what? What kind of address is that? Remember that? Class C, right? Class C, it's another kind. I know you know that. And we've got the default gateway there. And you'll notice again what I was meaning by that. Those are private addresses. These are RFC 1918 private addresses. So I've got to be able to ping that default gateway from here. I would check that first, on an exam, in a job interview, on the job, PC troubleshooting. The first thing you got to do is make sure that the PC first can ping itself. And if it can ping itself, then you ping that default gateway. Then you start pinging the things, whatever you can't reach. So there's a bonus troubleshooting lesson for you right there. Always ping 127.0.0.1 first at the PC level, then ping the default gateway. If you can ping the default gateway, then you start pinging whatever device the user can't reach, whether that's an email server, print server, whatever it happens to be. I would tell you 9 out of 10 times, that's the problem right there. In my experience and in the experience of most network admins, you can almost always ping 127.0.0.1, but again, it's the first thing you should do. But pinging the default gateway, that's usually where the problem comes in. That is usually where the problem comes in. Now, that is ipconfig. Let's look at ipconfig all. A lot more information here. A lot more information. You can see all kinds of information up here. There's the IP address, subnet mask, default gateway. There's the DHCP server. There's the DNS servers, when the lease was obtained and when it expires. So it's all good information to know. But again, ipconfig is a good one. ipconfig all is what I usually run, and that gives you almost all the information you need. And again, can't say this often enough, but I am just going to say it one more time. If a PC can't access network resources, make sure it can ping itself, but this is probably the issue. That's the most common problem in my experience. Here are some other ipconfig commands that you may find helpful. I'm not going to run them here on this PC while we're taping. That would not be good. But well, we could do a release and renew. ipconfig release will actually release the PC's DHCP assigned information. And ipconfig renew will actively ask the DHCP servers for an IP address and other information you need for connectivity, including the DNS server location. Netstat I don't use as often, but it's a good thing to know about. Netstat minus RN, that's not an M, it's RN, and that displays the host routing table. And again, it's my experience, and I would share that with you, that ipconfig all is really the best place to begin troubleshooting at the PC level. Check those cables, ping the loopback, ping the default gateway. 99% of the time, your problem is going to be one of those three things. Now we're going to go to the opposite end of the spectrum. We were just talking about what to do at the PC level. But what about the wide area network level? Let's take a look at that. Here are the routers we're going to use to walk through an example here. And this is our wide area network: New York, London, Paris, Munich, Mexico, and Spain. Now, if we have a routing problem on one of the routers here, we could hop on a plane and we could go look at the router manually. And then we could fly to the other cities with routers along those two paths. But I wouldn't recommend that. It's probably going to break your IT budget. So instead, we're going to use some or all of the tools that we're going to talk about for the rest of this section. Some of this will be a review, but it's a good review. And the first thing we're going to talk about is Telnet and SSH, because of course we're going to be using one of those two to connect remotely to one of those other routers. If we're in New York and we need to communicate with a router in Spain, we're going to Telnet to it or SSH to it. Now, we discussed both of these tools in depth in another section. We're not going to cover every password detail here, but a couple things to watch. Remember, Cisco routers do not allow users to connect via Telnet or SSH by default. That's a very good thing. A password has to be set on those VTY lines. Users who connect to a router via Telnet or SSH will be, by default, put into user exec mode. And we looked at that in an earlier video and we saw we really can't do a lot. We can look around a little bit, but we can't configure anything. For those users to have access to enable mode, you've either got to set an enable password and share that with them, or you can put privilege level 15 on the VTY lines, and that places the incoming user into enable mode immediately after they authenticate with the VTY password. Remember that Telnet sends all data in clear text, including the password. SSH encrypts all of that data, but SSH does require more configuration and possible extra hardware depending on the size of your deployment. Now, there are a few additional Telnet commands you'll find helpful when you have multiple connections open. If you have your own home lab or you get one in the future, which I highly recommend, you'll run into some of these. I don't use these a great deal in the field. I use them more in my labs than anything else, but you should know them for the exam. Now, if you have multiple Telnet sessions open, you can run show sessions to get basic information about each one. And again, it's a handy command. You can see what host you're connected to. And to reconnect to any given Telnet session, you can use the resume command followed by the connection number. Now, see, when you first open it, if you're either going to open it by IP address or by host name. You're not going to just type in Telnet 1. You're going to type in either Telnet Blondie or Telnet 100.111. Once you Telnet to it, though, and you suspend the session and then want to reconnect, you have to use the line number. And you can just type it in if you want to. That's what you've seen me do throughout the course. I've actually been suspending telnet sessions and then resuming it just by using the connection number. So you could type resume 3 here, or you could type in just 3. That's what I do. Let's bring the routers back up and I'll show you from the access server. And you can see there the 5 connections that I've got. This is an access server, by the way, that I'm on here with Bryant Advantage 2. And I am reverse telnetting to these 5 devices. Reverse telnet is not something you need to know about yet, believe me, but it's a lot like telnet. And you use the same commands, and you can see my active connection there with SW2, but you can see the connections that I've got, the host names. Their IP addresses are all the same because I have them in a pod set up that way, so that's not something you're usually going to see in the field, of course. But again, to resume connection to any of those devices, you notice I simply hit 1 and I go back to R1. I hit 2, I go back to router 2, and so forth. And if you hit enter without putting a number in at this prompt, this trips people up a little bit sometimes. It's going to take you back to the last router you were on. Now, to suspend a connection, or to suspend an open session, you're going to use this key combination. It takes a little getting used to. It's Control-Alt-6 followed by X. That is to suspend a telnet session. And that's what I've actually been doing here on the remote route on the routers. When you see me with 2 and then all of a sudden I'm back at this prompt, you can't see what I did there, but what I did at the router 2 prompt to suspend this telnet session and go back to my access server is Control-Shift-6 and then X, and that takes you back to it. So that really helps. Very helpful command. When you have a home lab, you'll be using this a lot, believe me. To disconnect an open session, you can use disconnect followed by the connection number, and you will be prompted to confirm this request. And then finally, we could use show sessions to verify that that particular connection's been dropped, and you can see that connection 2 is now gone. Interestingly enough, you can use the where command. Not many people know about that one. It's a good thing to know about. Show sessions and where do the exact same thing. Watch that on exam day. In the field, frankly, I haven't seen anybody use where in a long time. I'm sure somebody does. I still use write, so we can use old commands if we want to. But show sessions and where do the exact same thing. So I know we went over all the telnet rules and the SSH rules earlier in the course. It is a good idea to know these telnet session management commands, show sessions, then how to reconnect. You can use the resume command. So here we could use resume 3 or just the number 3, which is what people generally do. That's what I do. To suspend an open session, Control-Alt-6 followed by X. And then to actually disconnect, you can type disconnect and then the connection number. And then finally, show sessions and where do the exact same thing. So it's a good idea to know those telnet commands. Now hang in there because we are finally going to take a look at this extended ping here in just a moment. But let's review our regular ping results that we've seen so far. Now, there are other ping characters that you can see as returns, but frankly, the 3 combinations we're looking at here are by far the most common and the ones I would be aware of for your exam. Now, the 3 returns we've seen so far, you know, the good, the bad, and the ugly. We've got 5 exclamation points. That means we have IP connectivity to the destination. That's good. The bad is when we have 5 dots come back, or 5 periods, whatever you want to call them, because the IP connectivity to the destination does not exist. The ugly, and that's a good way to remember that because there are 3 capital U's in it, this is the one that really trips people up because they get it back. It's like, I don't even know what that means. Well, what it usually means is that the local router has a route to the destination, but a downstream router does not. And we actually saw that in action in another course. So we definitely have the good, the bad, and the really ugly there. And it's the third point there, the third example I want to bring to your attention again, because it's easy to forget that it's not enough for the local router to know how to get to the destination, because occasionally you look in a routing table and you see the route to the destination that you want to get to, and you send pings out and you don't get what you want, or your data's not getting there, and you're thinking, well, wait a minute, this router's got a route, what's the problem? Well, maybe a downstream router doesn't have a route. And let's take another look at that, and we'll use our network here. Let's say that we send a ping from New York to Munich, and the New York router has made a determination that the best path to Munich is through the London router, because we've got two paths. We've got redundancy. We love redundancy. And you might be thinking, well, how does it make that determination? We are going to talk about that at the end of this video, so hang in there. But right now, we're just going to make that assumption. New York, for whatever reason, has decided this is the way to go to reach the Munich router. So we send a ping, and it goes down to the London router. Now, if London doesn't know where Munich is, and doesn't have an entry in a routing table, and does not have a default route, then the packets are going to be dropped. And the ping result we're going to see in that case would be U period, U period, U. Now, there's one little problem from our viewpoint at the New York router here. We don't know which router sent that unreachable destination message. So we really don't know where to start troubleshooting. In this particular WAN, of course, it would be really easy because we've only got two routers between New York and Munich. But a more realistic one, I mean, boy, we could have 25 routers, 35 routers, 45 routers. And we need a command that's going to help us pinpoint where the problem is in the WAN. And the traceroute command is absolutely custom made for that. Here's a example of a traceroute I ran. And I'll run a live one here in a moment. Type escape sequence to abort, tracing the route to, and then it gives you the IP address. And then you're going to start seeing the IP addresses of the routers along the path. And when you begin to see the asterisks that I've included there, that means that we're no longer moving forward on that path to the destination of 208.109.62.234. And the last IP address that did successfully reply is 208.109.112.173. Now, by checking your diagrams, your network diagrams, and communicating with your service provider, you can identify the point in the WAN where the problem is. It's not always going to be easy. It's going to be digging, but if it were easy, everybody'd be doing it. But this is the command that really helps you pinpoint, hey, we're okay up to this point. Then we've got a problem. Now, this is interesting because you see those asterisks just keep on coming. Now, at the beginning of the traceroute output, and we've seen this earlier, I believe, type escape sequence to abort. Did you ever notice the router doesn't tell you what it is? And that can be pretty frustrating because these asterisks are just going to keep on coming, I believe, for 30 rows. And let's run that command live here and see what happens, because it's a little embarrassing, especially if you have someone who's with you and they're non-networking, and you know what they're going to ask? They're going to ask the musical question, is this supposed to be doing that? And you're going to be sitting there, yes it is. I'm waiting for the rest of the asterisks to come back. Well, you don't want to do that. So let's run a quick trace route live like that and see what happens. We'll bring our router back up here. We'll go back to the access server, which is a router, by the way. It sounds like a white box right when you hear access server, but it's actually a Cisco router. We'll send a trace route to that same IP address. And occasionally I catch myself doing this. This is the Microsoft traceroute command. So you have to watch that on the exam too. I'll talk about that in a moment. 208.109. And you're going to see a pretty fast string of IP addresses come up. And then you're going to start seeing these asterisks. And this is about the time you start thinking, I really wish I knew how to stop that. Now there, it did stop after 14. You can see that come up as long as 30. And they're just going to keep on coming and keep on coming and keep on coming. Well, we stop a trace route the same way we stop a ping. And that's when we get here. We'll get back to the timing out area. That's what it's doing now. Notice that it came back up to the prompt immediately. That is Control-Shift-6. Not Control-Shift-6X, although if you do that, it's going to stop at 2 because it'll see the Control-Shift-6. But Control-Shift-6 is the magic escape sequence for pings, extended pings, and trace routes. It'll terminate the entire process. Control-Shift-6. Don't tell anybody else that I told you that. It's a secret. It really is amazing how many people don't know that, but it's good information for the exam and for the real world as well. Now, Microsoft has a version of traceroute as well. It's TraceRT, as I mentioned a moment ago. Here are the options for it. Couldn't hurt to know that. I would definitely watch out for that on your exam. You know, is it traceroute or TraceRT on a Cisco router? It's going to be traceroute. On a PC, it's going to be TraceRT. Got a couple of options here. Not resolving addresses to host names. I like to use that one because I like to see the IP addresses. That's really the only options here that I use. But again, traceroute will handle that for us. Now let's get back to that regular ping. Let's go back to our routers here for a moment. And we'll go back to router 2. And I mentioned that extended ping. Now extended ping gives you quite a few options here, where regular ping does not. Now the regular ping we've worked with so far, nothing wrong with it. I use it all the time, so will you. But as you get into more specific situations, you may need options that the basic ping doesn't offer, because frankly, it doesn't offer a lot of them, right? So to use extended ping, here's how you do it. Notice that we are at the enable prompt here. Let's step back one level here, and we'll go out to the console port, and we'll go out to user exec. If I enter ping here and just hit enter, it's going to tell me incomplete command, because at user exec I can only use regular ping. You must be at the enable prompt to run extended ping. And to run extended ping, that's what you're going to see. It's going to start giving you prompts for questions. We're going to walk through a couple of these. This is not as bad as setup mode, and we're going to look at some of these. So again, keep that in mind. Very important detail. If you use ping, regular ping, you can do that from user exec. But if you're going to use extended ping, then you've got to be in enable mode. Now the first question we're asked is, what protocol do we want to use for these pings? If you see one option in the brackets, as we know, that's the default answer, and you can accept that answer by hitting the enter key, which is what I just did. And that's what I'm doing here. Now it's going to ask you for the target IP address, and I'm going to type one in that we can't hit. Actually, we'll type this one in. We'll see if we can hit it or not. 75.146.16.1. Now repeat count. This is an option I use often. By default, it's going to send 5 ICMP echo packets, and we're hoping to get the echo replies back. Now there are going to be occasions when you want to send a lot more ping packets than 5. If you're troubleshooting, and let's say you've got 2 telnet windows open, you're kind of working on a connectivity issue, what you can do with this is send 10,000 pings. And they're just going to keep going out and keep going out. And of course, as they time out, which is why you're there troubleshooting, they're going to be dots. But if you do something on the router and you suddenly see exclamation points, you know that you've got something going on. It's kind of like the heart rate monitor when you're doing it when a doctor performs an operation. He's got that screen up there that you can see what's going on with the heart. Well, if you open up 2 telnet connections, you can be working in one and continually sending pings with the other. It works out very nicely. So what we're going to do here is send 1,000 pings. So let's take that. Datagram size, we're going to keep the default of that at 100. Timeout in seconds. By default, the pings go out every 2 seconds. And since I want a steady stream of them, we're going to change that to 1. Now we get extended commands, and you notice the default there, the default answer is N for no. Here's a word of warning for you, and you'll see this with other commands throughout your studies. If a Cisco router asks you a question and the default answer is no, there may be a really good reason for it. What I always do when I see that, I just think one more time, do I really want to do what I'm about to do? Because you don't see no for a prompt that often in Cisco. It's either going to be yes or yes, no. At the very least, as I like to say, you should consider the question carefully. Now there's nothing harmful about the extended commands, and I want to show those to you anyway, so I'm going to answer yes. Source address or interface. Now by default, the source IP address of a ping is the address on the interface the pings exit the router on. That makes perfect sense. But on occasion, you may want to specify a different source IP address or interface for the source. Even that's pretty rare. That's more advanced. So we're going to hit enter here. And actually, I'm going to hit enter for a couple here. I'll let you see a couple of these. TOS, we don't care. DF bit there stands for don't fragment. We're not going to do that. We're not worried about validation, data pattern, any of this. This is really getting advanced. We're not worried about the sweep range. Type escape sequence to abort, and there we go. So our pings are going out. You can see 1 dot per second. And we could be working on the issue right now, you know, why can't I connect to this, etc. Then if we're working on another screen and we suddenly see exclamation points come up, then we know we're in good shape. But let's just say that, let's say we put the wrong IP address in. Oh, I didn't mean to do that. I don't want to watch 1,000 dots here. We don't want to do that. And once you see connectivity is up and it stays up, you may want to terminate the ping as well. And remember that keystroke? That's a real lifesaver there. Control-Shift-6. Because otherwise, if you don't know that, you've got to sit there and watch 1,000 pings go out and not come back, and you don't want to do that. So again, that keystroke, Control-Shift-6, terminates regular pings, terminates extended pings, and it terminates trace routes. Very helpful. And again, extended pings, the more specialized situations you get to in networking in the real world and during your studies, you'll find this useful. The main reason I use it in the field is to be able to send more than 5 pings at a time. I don't want to try something and then have to stop and send a ping out. I'd rather just go ahead and start sending pings as it is. But again, what you want to do is watch this, because you can't send an extended ping in user exec mode. Remember that when our users telnet in, they're in user exec by default. This is one of the reasons why they set ping up this way. Because if you have a tech support person that you allow to telnet in, maybe you want them to be able to ping something, but you don't want them to be able to get into extended ping and start setting all these options. So that is the reason that you can use only regular ping in user exec mode. To use privilege level ping, if you will, or extended ping, you've got to be in enable mode. Let's revisit our WAN and a statement that I made during our discussion of pings and trace routes. I said that the New York router has made the determination that the best path to Munich is through the London router. Now, as a future Ccna, and however far you want to go, the NP or the IE, but you want to be a world-class network admin, you need to know a little bit about how that determination is made. Now, I know the only routing protocol that we have studied to this point is RIP, and you'll be introduced and master OSPF and EIGRP during your ICND2 study, should you choose to go that far to the CCNA, which I certainly hope you'll do. Now, I'm going to mention a few other routing protocols here. You are not going to see EIGRP configuration on the ICND1 exam. You're not going to see OSPF. But it's a good idea to know a couple of numbers that I'm about to present you, and to be able to look at a routing table and say, okay, here's the best path and here's why. Because if a router has only one path to a destination, obviously that single path is the best path. Now hopefully our network has redundancy, just as our WAN example does, and I'm about to make things a little more complicated and add another router here. This time we're going from Mexico. And let's say that a packet comes into the Mexico router and it's destined for 191.168.32.1. It's trying to get to that PC at the right-hand side of that screen. Well, we've got 3 possible next hop IP addresses that I've listed under the 3 routers. Now, this is the kind of redundancy we love, because even if 2 paths go down, then the third one can be used. But if all 3 are available, most likely one of them is going to be chosen. Now, you'll learn more about that in your advanced studies. But we're going to go under the assumption here that we're going to have a routing table from heck, and Mexico is learning about these next hop IP addresses through 3 different protocols. And again, I hope you never see a routing table like this outside of your exams, but this is a good way to illustrate that you understand how the router is going to make that decision. So if we're looking at Mexico's routing table here, we can see that packets destined for 192.168.32.1 would match all 3 of these entries. That's pretty obvious. But the key here is we have 3 different IP addresses for our next hops, and you'll notice that they were learned by 3 different routing protocols. This is your first introduction to the fact the letter D actually stands for EIGRP. That's because there is another routing protocol, EGP, that came first. I'll show you that too in the routing table. And I have a table. Yeah, we've got the codes and that directly connected network. Just a reminder, D indicates an EIGRP route, and because EGP came first, and there it is. So that's for future reference. Just keep that one in mind. But we've got these 3 different routes determined by 3 different routing protocols. Now here, what we call administrative distance does not matter, because what we're looking for is the longest match. And what we're looking at, or what the router's looking at, is that prefix length. And 26, we know what that is. It's prefix notation. And that is the longest match right now, because it could be sent via any of these 3 routes, but this one's got a prefix length of 26, this one's got a prefix length of 24, and this one has a prefix length of 19. So in this particular scenario, this path would be the preferred path of the 3. Now, what if the routes for the destination are all exactly the same? Now here we have the exact same scenario. I did change the next hops a little bit, but they're all different. And notice the prefix lengths are the same. So the longest match rule, as we call it, is not going to suffice here. That's not going to get the job done. When routes are received via different protocols and the longest match rule does not result in a route selection, the administrative distance is the tiebreaker. And that's what I have in bold here in the brackets. That's the administrative distance. Remember, this is the metric. RIP just uses hop count, so it's 4, and that's 4 hops. OSPF and EIGRP, as you'll see in future studies, both use more complicated formulas for best path selection, so the metrics are going to be a lot different. But you've got to know that the first number inside these brackets is the administrative distance, and the second is actually the metric for that particular path. 2 key points about administrative distance. Administrative distance is the measurement of a route's believability. The lower the administrative distance, the more believable the route. And this is one time, bigger is not better. It's not better to have an AD of 255. It's better to have an AD of 0. That's when you're actually the most trusted route type. And again, AD only comes into play when there is a tie in the longest match route comparison, as we looked at with our little routing tables here. So here, again, the EIGRP route would be selected because it's got the lowest administrative distance. The prefix lengths are all the same. So the router considers the believability of the route sources by looking at the administrative distance. And it says, okay, EIGRP by default, that's got an AD of 90. OSPF's is 110. RIP's is 120. Therefore, I believe EIGRP over those other 2 routes. Now, you might see a little bit about this on your exam. I would expect you to see a little bit of administrative distance. And I would go ahead and memorize all these because you're going to need to know them for future studies. I would know the route source and administrative distance, particularly directly connected routes. That's the most believable kind of route, period, because the router is already connected to it. The router is actually already connected to it. A static route by default has an administrative distance of 1, so it's almost the most believable kind of route. EIGRP summary, I wouldn't worry about that until my NP studies, frankly. Internal EIGRP, that's really the EIGRP that I was just showing you. That's got an AD of 90. IGRP is pretty much gone, but you might bump into it in the field, AD of 100. OSPF has an AD of 110. IS to IS, you won't even see that on your ICND1 exams. But in case you want to know, it has an AD of 115. RIP we've worked with throughout the course. It's got an AD of 120. I would not concern myself with these higher values yet. But if you see an AD of 255, that means it's totally unbelievable. So the ones I would really concern myself with, directly connected, static, OSPF, just know that one, RIP especially, and EIGRP, that's the EIGRP that we were just looking at. And again, if you really want to save yourself some time, you can just go ahead and memorize them all because you will need to know them for future exams. Now I'm going to show you a little trick with static routes, because at times you may not want your static route to have an administrative distance of 1. Let me show you how to change the distance, the default distance on a static route. And we'll just put in a host route here, right? That's what that is. And clear my screen here to get rid of that other stuff. You'll see here then with iOS help, this is what I really wanted to show you. We saw this a couple of times when we were talking about static routes. We didn't use it. This does not have anything to do with the distance from point A to point B. That's kind of the way that reads, distance metric. This is actually changing the administrative distance of a static route. And it's a floating static route. Let's say that we were running OSPF on our entire network. Actually, we'll use RIP since that's what we've been using. Let's say that you wanted to write a static route to a destination, but you want it to have a higher administrative distance than RIP, so that RIP routes will actually be considered more believable for that destination than the static route that you write. So if you chose to do that, we could get cute and just set this to one number higher than the administrative distance of RIP, and that's 121. Again, you could see that, you may see that on your exam. Just watch that number at the end of it, because you will see those in production networks. They're called floating static routes. And what they're basically used for, they're kind of like backups. If the dynamically discovered route via RIP leaves the routing table for some reason, we want this route to go into the table. What we do is we write it, but we make sure to give it an AD of 121. Therefore, a RIP discovered route for this particular host, this particular network, would be considered more believable. But if the RIP route disappears for some reason, then you've still got this route, and it would then be put into the routing table. Again, just kind of look out for that on the exam. If you happen to see a static route with a number at the end of it, you're not going to be asked to really get into floating static routes. That's more of an advanced skill. But I wanted to let you know why we use that instead of just pointing it out. But watch out for that number at the end of it, because that means that someone has changed the administrative distance. And again, this is an excellent table to go ahead and memorize. And once you start working with a lot of these, with some kind of hands-on practice or in production networks, they'll be second nature to you. They really will. Now I want to talk about that a little bit, and it's something I've mentioned throughout this video, because frankly, this is probably my favorite video to teach and my favorite skill to teach. But a lot of troubleshooting, it's a learning experience. I've been in IT for well over a decade. I mean, I started out, doing the usual thing with printer setups and printer troubleshooting, that kind of thing. I've been doing it for well over a decade, and I learn something new almost every single day. I truly do when it comes to troubleshooting. I personally love it, and frankly, that's what we do most of our time as network admins. We're not always installing brand new equipment and configuring it. We're troubleshooting what we have. And I'll just tell you from personal experience, it really is about knowing the fundamentals and having that structured approach I've talked to you about. You don't want to be the person that just sits down and is kind of panicky already and just starts typing and just hoping something happens. You want to have a structured approach. Start at the physical layer. Check those cables. At the PC level, ping 127.0.0.1. If you can't ping 127.0.0.1, then you know where the problem is. If you can, what's the next thing you do? You ping the default gateway. You have that structured approach. Of course, you have to be flexible, But when you have that structured plan before you sit down to troubleshoot something, I don't care if it's a PC, a switch, a router, a printer, or anything else, when you know the fundamentals and you develop your own structured approach, this is what I'm going to do, ABC, you will be absolutely, totally unstoppable when it comes to questions in the exam room and dealing with real-world networks. I kid you not, because once you can really troubleshoot in this business, you can make your own future. And I mean that. You can absolutely write your own ticket down the road when you are a world-class troubleshooter. One more thing I want to show you as we wrap up here with iOS Help, and it's just one more tip that'll help you on exam day and in real-world networks. You know that I've continually told you use iOS Help even when you don't need it, because you can see other options and it does help you learn, and you can see I used it there to see what the next options were. What will happen on occasion is you'll be working with a command and you'll say, you know, I haven't used that in a while and I know it begins with CO or something like that. You can't quite come up with it. Well, what I've done generally during the course is left a space here between whatever I had here and the question mark. And that shows me the next options. But if you start a command like conf right there and you're like, you know, what's the rest of that? What are my options here if I have con? I can't remember what the rest of that command is. You can use iOS Help without putting the space in, and it's going to show you the proper options there, the ones that you have. So we're in enable mode. I've typed CON, and the two commands that begin with CON are configure and connect, and then I'd look at that and say, oh yeah, it's configure. Because if I try that, if you get that ambiguous command message from the router, what that means is there are multiple commands that begin with the letters that you put in, and you need to tell us what you want to do. Because, of course, we abbreviate all the time. Configure terminal, once you have that command down, you're going to get tired of typing that, so you'll end up doing what we always do in this business, and that's just typing conf t. And of course, if you forget that you've got to put another option in, it'll generally ask you, you know, are you configuring from terminal, memory, or network? Well, it's terminal, and we go from there. But watch these two different uses of iOS Help. They're not going to try to trick you on the exam, and I'm really mentioning this for real world, but there's a big difference between putting this in and putting that in, because that space means everything. If you leave the space out, then it's going to show you the different options you have for whatever you put in. But when you put the question mark in, you're assuming, okay, I got the con part right, what are my options here? But if you see ambiguous command, that means you didn't give the router enough to go on to decide which command you wanted to use. And boy, if you put the word C in, you see we've got 6 different options. CO, we've got 3. CON, we've still got that. Conf, that's enough right there for the router to say, okay, you mean configure, because there are no other commands there that begin with CONF. So that's a good memory jogger, you know, because we'd like to be 100% all the time, but we're just not. Sometimes we have to go in on a weekend or early in the morning, late at night, and you're a little tired and you're not thinking clearly. And it's like, what is that command that begins with CON? Well, that's how you see it, is conf t. So again, we'll jump out of that. Want to thank you for hanging in there. There's a lot here, and like I said, I've taken pains here not only to put troubleshooting in throughout the course, but in this particular video to share some real-world experiences with you and some real-world troubleshooting tips. Because again, dealing with the human factor, it's not something you're going to have to do on the exam, but it's definitely something we have to deal with in the real world. Because no matter what I've been called to troubleshoot, whether it was a printer or a router or a switch or what have you, it's not just the device that we have to deal with. It's the person standing next to the device, and sometimes that can be even harder to deal with than the hardware itself. So again, I want to thank you for your time. I hope you enjoyed the video, and I will see you on the next video.